Good morning, everybody. My name is Davide Mancino, and I'm a visual journalist and an information designer, and contributing to Il Sole 24 and other news outlets in Europe and in the United States. So, what I'll be talking about, what I'm giving you is a very quick view of how the process works for a visual journalist. So, the very first step for a visual journalist, for every journalist these days, starts with finding the data. Basically, there are four main ways by which you can find data. The most common, which I'm sure you all know about, is very classic PDF files that comes from an institutional or an academic source. And from a visual journalist standpoint, this is, as I said, the most common situation, but it also not the best, because most of the time to get the data out, you have to, there's not a very fast way to do it, you have to clean it and so on. So it's the most common situation, but it's not really great. On the other end of the spectrum, there are data warehouses, such as this nice one of the OECD, which provide us with lots of data and pretty good data, and ways to extract it very, very quickly. This data is, this situation is probably the best, because you have the cleanest data you can get, and the fastest way to use it. But at the same time, this data tends to be only about the most common topics. So it depends on what you're working on. If you're lucky, you'll get it here. But if you're not, you have to get it somewhere else. The third situation you can come to is when you need to scrape data. So in this case, what I'm showing you is the result of the Italian election in 2018, where the results were put in real time on this website you're seeing here, but there was not a way to download them in real time. So what we had to do is to write a script to download them and transform them and make them into a way in which we could use them. So the way to do this here is to build a script that can get you from this to this, and this can be a very useful skill, but at the same time, you have to learn to code. You can do it 99% of the time. You can do it in with a software or in an automated way. So it can be pretty slow. Last way is also an interesting one, and maybe perhaps the least used way of getting data, which is crowdsource. This way, you can basically just put out a form and let people fill it with information. Of course, as I'm sure you know, these can have all kinds of issues, starting from the fact that it will likely not be a representative sample of what you're looking for. But still, it might be a way to get data where there's really no other way to do it. So those are the four main ways journalists and other analysts get data. But once you have it, you have to decide what to do with it. Because just because you have data set doesn't mean it's useful, doesn't mean it's true, doesn't mean it's interesting. That's also a factor, mainly for journalists, but I'm sure also for academics. So once you have the data, you have to basically, we just look into it and try to find it if there's a story, if there's something interesting, surprising, which we didn't know about or we think people should know about. And then comes the fun part, visualizing the data. So this chart or charts was made by my colleagues at the Financial Times, and they made an amazing job in synthesizing what you can do with data. And as you can see, there are dozens and dozens of ways to represent data. And this can be really a nice starting point to decide what you want to do with it. So as you can see, depending on the data and how you think about it, there are several ways to show it through data visualization. You may want to show deviation of the data, correlation between data, ranking, distribution, and so on. And for each of those categories, there are several type of charts you can use. Among those, there are the classical ones. You can see line charts, column charts, bar charts, and so on. But there are also more unusual ones, which we'll get into a little later. But this, I think, it's really a really great starting point to decide what you want to do, with the data. So I'm giving you a few examples of what the end process of all this is. So let's start with this. This is a very simple bar chart, and I'm showing you this because when you start visualizing data, and I also did this. I mean, when you start visualizing data, you get to a point where you get what it means, and you start getting bored. I mean, you can do another bar chart for the 29 times again, and that's not really true. It's not necessary to be fancy just for the sake of it. A simple bar chart many times is just perfectly fine. It's simple, everyone will understand it, show you the data. You don't need to do complicated things just because you want to do them. Another important thing that I've been learning, doing this for a few years now, is that visual literacy is increasing. Charts are basically everywhere, and people are getting more and more used to them. So we can start using them. We can start using even charts that a few years ago were maybe a little more complicated for the average person. So for example, this is basically a simple scatter plot that plots the average income of people and the employment rate of people based on what they studied in college. And its purpose was to show that scientific courses were leading people to better outcomes in the labor market. So it's a very simple fact. But at the same time, if you had shown this chart to people like 10 years ago, I'm sure many of them wouldn't have understood it. But now instead, I'm sure more of them are getting used to it and seeing this type of charts, even in major news outlets. So this is pretty good, and it means that we can start getting more complicated. Also, I want to just talk 1 second about maps. They are great, I love them, but at the same time, they tend to be a little overused. I'm sure they look great, and in many contexts, in many situations, they can do a great job. But for example, if you have like 10 data points, 10 regions, you don't need to use a map because it can be maybe a little difficult to distinguish between the color shades, and they're not as easy to read as people think when it comes to the difference between each geographical section. So maps are great, but maybe they're a little overused. Another corollary of the increasing visual literacy that we can surely start using more unusual chart types. So for example, this is called a Sankey chart or a flow chart, some call it. That represents where people come from, depending on their education and where they go live. So this is not a type of chart that you see super often. I mean, you lately use, I'm sure you will see it more often than in the past, but it's not a classic chart type like a bar chart or a line chart. But with increasing visual literacy, I'm sure we can start exploring a little and pushing for more advanced graphic design and chart design that we weren't able to do a few years ago. The only thing is we need to make sure that our readers understand what we are trying to tell them. And this is the most crucial point. Whatever the chart we do, however we use data, the only thing that matters is that people that read them understand them. If that's not the case, we are making a mistake, and it's on us. It can be on them. Once you get to a point where you know the readers can follow you, it starts to get very fun. So, for example, this is a work I made for a publication that, luckily for me, has a weekly section dedicated only to data visualization. So we know the readers are used to it. The readers will take their time reading the charts and the visualization we make, and so we have the possibility to do more complicated things, to experiment a little. For example, this is a visualization about building heights in some European capitals. And you can see that when you start working with geographical data, it can get very fun, can do very nice things. And there's a lot of data going around that nobody's using. So it's also fun to discover new things. This means also that when you think it's the case, you can get more experimental. So for example, this is a visualization about power plants in Europe. This is basically a map, even if you don't see the borders of the countries. But each of the bubbles that you see is a power plant, colored with a different color. If it's a nuclear power plant, it's a renewable plant, or so on. And with the sites that varies with this power output. So as you can see, this is a pretty strange chart, and I used it to experiment with various types of charts. These maps at the same time the number of plants, their distribution, and their density. So this is really 3 or 4 charts on top of each other. So this is a pretty experimental design, but this is one of the things that you can try to do if you're confident enough that reader will follow you. Of course, it might also mean that in the end they won't understand it, but it's also a useful data point. It means you push too far, and maybe you need to do a simpler things next time. The last thing I want to show you is this visualization. This is interesting, I think, because it was in a way the last resort of visualization, because most of the time you have some crutch to use. You have some software, something that do part of the work automatically. This was not the case. I had to map a few hundred small Italian cities, depending on what their best attraction was. So you either go there for the food, to the sports, for nature and environment, and so on. And each one of the city could be divided into mountain cities and other type. So I had to put all this information, and I didn't want to use a map because you couldn't see the cities because there were only a few hundreds. You're never going to see them on a map. So what I did was thinking about a visualization like this, in which we have 20 squares for each one of the Italian regions, and each one has a number of the cities involved. So there really isn't a way to do this with the software. I mean, you could build a script to do this, but you take 3 times the 3 times the time you take to doing this in other ways. So when there isn't a script to do the work, you just do it your way. So just build all the elements manually. In this case, I did it with the Adobe Illustrator, and so that's it. When there's no other way, just do it.
Hi, everyone. Thanks a lot for the invitation. I'm sorry I can't take part in the live session, but I hope you'll find this short video helpful and informative. I'm Esteban Ortiz-Ospina. I'm an economist. For the last 6 years, I've been working to help create a web publication called Our World in Data. In this web publication, we cover many different topics, but you've probably seen some of our work recently in the context of COVID-19. Today, I want to tell you a bit about my work and the work that we do at Our World in Data, and share some lessons that we have learned that might be helpful for you when communicating with data for the general public. So what is Our World in Data? Our World in Data is a project that is really a joint effort between researchers at the Oxford Martin School at the University of Oxford and a nonprofit organization that we created that is called Global Change Data Lab. And this nonprofit is responsible for the publication of the website. So it's where we have and where we create all of the kind of data tools and the actual web development that is required for our work. And we are a small team of about 14 people, and we're split in three different groups. One group does the kind of research and the writing of the content that is published on the website. We have another team that is responsible for the data management and all of the kind of data pipelines that feed into our central data system. And we have a web development and software engineering team that is responsible for producing all the data, all the tools, but also just the actual website that is published. So what is our World in Data about? What's our mission? So basically, our purpose is to help make data and academic research accessible and understandable. And the main idea is that to tackle global problems, we need to rely on solid research and data. And often there's great, fantastic research and data that is hard to access and hard to understand. And that's because it's behind paywalls, it's buried under jargon, it's scattered across specialized sites that are hard to find and hard to navigate for journalists, students, and policymakers, and the general public. And so that's what we try to do with our World in Data. We try to make it easy for people to access and understand this knowledge that already exists. And I think a key kind of underlying premise behind our work is that, as you know, as social scientists working in mainstream academia, we're trying to look for gaps in the literature to publish academic work, and that's fine. But this makes it actually easy to forget that there's often kind of a pretty high return from investing time into just getting existing knowledge out in the public domain. And so that's what our World in Data is about. And I think probably the easiest way for me to show you what our World in Data is to just share my screen and go together through an example. So I'll just do that now. And I have here Google. So this is actually how many people come to our site. They look for data on something. So let's go for something like CO2 emissions data. So if you put that query here into Google, the first link that comes up is our World in Data. And so if we go there, we see that we have basically this page that has some text and a series of interactive data visualizations here on the right-hand side. And we basically have everything structured with sort of short segments of text with a lot of signposting and some headlines, and this kind of side-by-side text and chart blocks. So here in this table of contents, you can see how we've structured the kind of subtopics that we have for this entry. So if we go here to per capita CO2 emissions, what you will find here on the left is some text that explains what we are seeing here in this chart. It has links to academic papers and to other resources. And here in the chart itself, we have a number of tabs here and some information that is also kind of helpful and relevant to make sense of the data and the chart itself. So we have a subtitle that gives us some important information about the metric that we are seeing here. We have information about the source, and we have a footer and little note at the bottom that is also telling us something important about how to interpret this variable. In the tabs at the bottom, there's a chart tab where we can plot lines, sort of a time series version of the same data set. We can also go to the table tab where we can see a table version of the same data. And there's a sources tab where we can read more about where this data comes from and what exactly it is. There's also links to the underlying resources and publications that made this work and this data possible. And we also have a download button here at the bottom, where we get access to a CSV file that takes us to download all the data that is behind this chart. And we can also download a static PNG version of this. So it's, that gives us a chart that we can share in social media, or that we can put, for example, in lecture slides or something like that, or in news articles. I also want to show you that here at the top, we have this kind of navigation panel with related resources. And one of them is our Data Explorer. And this Data Explorer allows us to explore the data, all the different metrics and all the different variables that we have for this topic in one place. And so we have here not only CO2, but also emissions from other greenhouse gases. And we can, for example, change between per capita, per country, cumulative, and so on. And the other thing that so we have here, again, at the bottom, the same tabs. And here at the top left, we have a link that takes you to GitHub, where you can download the entire data set that is behind that Data Explorer. And it comes with a kind of standalone dictionary and an explanation, a code book of what that entire data set is and where it comes from, what it all means. So I'll stop sharing my screen now. And I just want to now kind of summarize our approach in a couple of points. So the first thing is that we present data in charts, as you've seen, but we also provide side-by-side a simple review of the key trends and an overview of the relevant research that is related to that data. We make it easy to access the data, so we use interactive charts and data explorers, and we also allow data downloads right at the chart level. So you can download an excerpt of the data set, or you can go to GitHub and just do a bulk download of the entire data set. We also try to optimize our content for the web, and what that means is that we try to make it easy for search engines like Google to index our content. And that's important because that makes it easy for people to then find what they're looking for when they go to Google. And a big part of making sure that the data is easy to understand for search engines is this kind of close link between the narrative and the commentary and this kind of text that is on one side and the actual charts and the data on the other side. We also try to keep our data exploration tools simple. So if you explore our website, you will see that essentially all our charts are basically maps, line charts, bar charts, or scatter plots. And we try to keep it simple and rather focus our energy in making sure that those simple charts that we have work well, are reliable, and are fast. So we don't do kind of fancy one-off interactive projects on the side or for specific, not at the moment. And finally, I think that the last point here that I want to emphasize from our approach is that we rely on the work of others. And in turn, we try to make it very easy for others to build on our work. So we are set up as a nonprofit. Like I said, all our tools and the actual website is produced as an open source project in GitHub. Everything is open access. We don't have kind of logins or paywalls or anything like that. And everything has a very permissive, or all of our content is copyrighted with a very permissive Creative Commons license. So that's in a nutshell our approach. And I just want to take now a couple of minutes to just share some lessons that we've learned that might be helpful for you when it comes to visualizing and presenting data for the general audience. So the first kind of recommendation is that you should always aim for clean, simple, machine-readable files. And this will allow experts to engage with your research and try to replicate your results, but also it will allow non-experts to get the basics right and really understand your work. The second lesson here is that the documentation, like these code books, these dictionaries, all of these kind of other information that is important to make sense of the data is actually super important. So you should make it really easy for people to understand where the data comes from, how it was collected, when it was collected, what are the actual exact crucial definitions to make sense of it, when will the data be updated, what is actually the source that you are using. All of this information should be easy to find, and people shouldn't need to kind of read the entire academic paper, for example, where you've analyzed this data to be able to engage with it. And I think in academia, charts and figures often use captions, and so on. They're extremely hard to interpret for people who are not familiar with the topic and who aren't sort of reading the academic paper from top to bottom. So I think here it's just important to understand that charts and data sets will be in many ways outputs, sort of standalone outputs, and you should try to make it easy for people to use those results from your work as sort of standalone pieces. And the last point that I want to emphasize is that if you're going to try to make your data public and accessible and make it easy for others to build on your work, you should think about maintenance, sort of think about how this is going to be in 3-5 years down the line. I think many people in academia, but also in international organizations, often want to showcase their work in new kind of fancy dashboards or data portals and end up investing a lot of time and resources into this. And I think that often then it's very expensive, but it's very hard to maintain. It also makes it very hard to make quick corrections and to run updates. Often people ask me for feedback or ideas for how to do kind of new dashboards and things like that. And most of the times my feedback ends up being to just use sort of out of the box tools, put your data and code in GitHub in a clean, simple CSV file with a nice, clean code book. If you want to make an interactive data visualization, that's great. You can import that into a tool like Data Wrapper. You can make a simple chart. You will get a link. You can share this link as a standalone chart, but you can also embed this in a blog post or anywhere else. And this will make it a lot easier to maintain and update over time. I think that's it for now. If you have any kind of questions or want to talk about more about the work that we do at Our World in Data, feel free to send me an email. You can find my details directly on our website at ourworldindata.org. Thanks a lot for your time and have a great rest of your day.
Thanks for the invitation. I'm really glad of talking about data communication because it's a topic that really interests me, and it will be a pleasure. So just to let you know about my background, I have a kind of a mixed background. I was an academic for 10 years, around 10 years, and then I moved to journalism like 5-6 years ago. So and in between I was a blogger. So the data communication was the reason why I moved from academia to journalism. So, and now I'm working at El País, which is the place where I'm publishing most of my work. So I have a large presentation. I will be jumping from here and there. So, but I will start talking about COVID. We have been working a lot during the last year and a half. And we started very early at El País because, unfortunately, as you know, Spain was hit very soon and very hard by the COVID. So we started publishing pieces about data stories about COVID on March 3rd. We published our first charts about the coronavirus, and we published our first data tracker that we are all doing now on March 8th. So, and this was a very demanding experience because we have nowhere to look at. Then we all have been working on this, but we were one of the first media working on that. But we have learned a lot in this month. So some ideas, some advice from these last months. This is our first chart. This is the first chart we published about COVID in March 8th, and I think it's a quite good chart because we make some good selections. And first of all, we were putting many countries in the chart, and the pandemic was still not a pandemic. It was not still an official pandemic. This was an editorial decision. We were thinking that this is going to spread. And the chart was trying to communicate that there are a lot of countries in the chart. Then we make the selection of using a logarithmic scale. This was controversial at this point, but I think that this was the good choice because the main question we had at that moment when we were putting this chart into the world was, is this spreading or not? And to talk about an exponential growth, the log scale is the technical solution. The discussion was, is this too much for our audience? They are not going to understand that, but you can explain things. If something is relevant, you can explain it and people understand it. And I think that this was a good decision here. And finally, the third decision here is our main chart to talk about COVID has been these simple chart lines. Why? And this is my second point. I want to miss that. It's very important to choose the right chart. And here, I think that the line charts are the better ones because they put together two pieces of information that are very, very relevant to talk about COVID. First of all, the chart is saying to you how much virus is in a region. The level of incidence is 100, 200, 500. This is the situation. This is the current state. But as important or more important than that is the trend. You want to show the trend. The trend is, because now we know that basically the virus has those two modes of operation. It is growing or it is decreasing. So the way of putting together these two pieces of information, there is a lot of virus, it is going worse or better, is to use a line chart. Any other solution is not that efficient communicating these two pieces of information. So this was the reason behind. Another useful idea from COVID, very simple, I will go quick here. It is very often useful to put many similar, the same chart, repeat the same pattern several times. This is called small multiples. We professionals of data visualizations, we use this a lot, but this is not used enough in other areas. And it is very, very efficient. You have your pattern. It's easy to understand one chart. Then if you give me 100 charts, it's very, very quick to scan from them and compare them. And this is very easy to implement, and it is it's quite powerful. More ideas taken from COVID. Pay attention to your charts. Charts are a super efficient way of communicating information when you have a complex issue at hand. You maybe are discussing if you have to talk about total number of deaths or deaths per capita, or maybe it's cases what is more interesting. Then one way of not putting a lot of data in your data is using a chart. Charts can be overwhelming, but you can use color, use the design to highlight the most important column, but at the same time keep all the other data here. And this is, of course, in a paper, it's the standard way of communicating a lot of data, but to a general audience, you can use that also very, very efficiently using design to separate the most important things from the less important ones. And regarding this, tables have been, for COVID, are often more useful than maps because maps are the opposite. Maps do not allow you to put a lot of information in the map because you are using the coordinates to geographical information, so you don't have enough space to put other information. And this is the reason why I think that maps were not that successful to talk about COVID. But of course, you can do a lot of super useful things with maps. We were working with maps a lot in the year before, so we can talk about this idea. So this is some ideas about COVID. Going to topics, more general topics, I will go quick here. So some lessons, some advice to communicate data. And the most important thing to do is to show the data. This is the main idea you have to have in your mind when you are communicating data. The objective is to make this communication the most efficient possible. Example, we were looking at this data from Google. They were measuring the mobility in all the world, in reality, and at different regions. And they put this information in a PDF. You can download it and you can take a look. And this was published for months. But when The information was there, so we don't have, the information is not ours, but I think that the good solution to show those data is to put all the data in a map. And you have to work in, the map was not a simple one, because you have to have different administration levels, but this was the idea to see patterns that were impossible to see when you were dealing with the PDFs. And this is what you are trying to do every day. Another idea, good communication matters. This is of course obvious, but we often forgot that. My main advice here is how can you do that? How can you communicate better? And my first advice is that trying is the first thing you have to do. It's not something very complex. It's not that difficult. If you put effort on how can I communicate better, you are going to do it. It's not something clever at all. Examples, or one piece of advice related with that. The most important piece of advice to communicate data is to integrate charts and words. Yeah, your starting point is that charts and words belong together. You are writing a piece and you are making charts, and they are completely integrated. You are not putting the charts like a complement or like a photo. This is not the purpose of charts. They have to be integrated. This is an article about young people in Spain. The topic is not relevant, but you can see here I'm writing the piece myself, and I'm choosing exactly when the charts appear, and then I'm integrating all, and I cannot move the charts from one place to another. The piece has no sense. For instance, more tips here. The content you put on the caption, the title, the first piece of information you are communicating, you have two missions here. Catch attention. It has to be something interesting or try to engage with your audience, and you have to convey main ideas. Both things, if you are communicating into the wild. An abstract in a paper is mostly devoted to two, but you have to think in the two objectives. Second idea, if you have data, you have a nice chart, you have something nice, put it as soon as possible. I make an effort, very strong effort, to do not write a lot before my first chart, because I was to send a message to my readers that I have data. And the way of sending this message is to show the data. Then I can write more, but this is important. Oops. I can use lists, some other tips. And as you can see here, all the charts are in the same style. This is important, but it's not that relevant. But I will put the slides. Okay, I will tell it at the clock. Okay, more advice. This is not for you, because you do know that analysis is more important than data. You know that. This is a message I often convey to journalists, but you here know here. But the idea is all the things that you are associated with scientific stance, to how to do science, is relevant to communicate complex stuff. You know the stuff. Just in is that when talking about uncertainty, you researchers, you know that the world is uncertain, and communicating uncertainty is very important. My advice is, of course, it is important, but more readers are not scared of uncertainty. They know that you don't have all the answers. They are clever in that way, and they are not expecting you to solve the issue at hand. They want information. They want to make their opinions, but they don't need to. You don't need to be scared of uncertainty. People, you have to be scared of abstraction. But uncertainty is a different thing, and people is okay with it. Abstraction is a different thing. I think I'm gonna. This is an example of this is a statistical model to predict elections. based on polls, and I'm publishing this kind of work in a general journal. So, but this is something that you can do. If you have a complex story to tell, there are some tips. For instance, put one good idea is to put the easy first. I have here a model that is a model simulations, and I have histograms and I have probabilities and all this kind, but I'm not putting that in my first chart. My first chart is a pulse average, because everyone can understand a column chart with. So the structure of the text you can adapt to the audience. So I put the easy things first. If I have details, I can put it on the end, and of course you can have a very detailed methodology at the end. Some people is going to read it. So you can you can play with the structure of your text to convey complexity in a simpler way. And one of the an advice I have to use, put the easier stuff at the beginning. Okay, I'm going quick because I think I'm on time. Yeah. Very briefly, try to write simple and clear. This should be the standard way of writing. You are here for communicating, so use this. This is better because it is that Twitter and Twitter threads. It's a good place to learn how to communicate, because you have feedback. You can see, oh, this thread is interesting and it has a lot of engagement. Can look, and you have a lot of researchers that are sharing threads in Twitter, and it's a good place to learn how to do it, because you have a complete feedback. You can do that every day, so it's a good idea. I'm going to miss this is much something for journalists. I'm going to pass this because I'm going to, which is the following. We are doing at El País, we are some problem with the slides here. Second. Okay, we are doing this kind of A/B test. So we are testing different titles for our stories, and I can say to you, for an example, that it's easy to get to double your readers just by changing the caption. I have the same article. It's put in our webpage at El País homepage in the same position. I'm testing A/B different, and I can see very 200 clicks increase percent when with one title with versus it's a quite good experiment. It's the same web page, it's the same time, it's the same position, everything is the same story, is the same author, but I'm changing the title, which are similar very often, and you have you increase by 2x your engagement with your audience. So it's very important to communicate better if you want to engage. And the final message is, the idea is very simple. It's attention. Attention is a market. You know how to play with markets, and you have to act accordingly. And this is the best summary I can give you to how to communicate better.
So good morning, everybody. I'm currently in Frankfurt. Enrico is in Italy. We are both experts in financial stability, and we would be sort of what the people could call as a data scientist in this context. And we're gonna try to give you an idea, a bit more serious topics, in particular how we use visualizations and data communication for systemic risk monitoring. So today I'm gonna give you an overview of what we do and what data we use, because we're not very familiar with us, so with our roles, and so I think maybe a sentence or two could help. What we're going to do in terms of making sense with communication about the complexity of the financial system. We heard this word also by Kiko before. Complexity is really an issue, in particular for some kind of data set. And in as example of what we do, we're going to give you 2 examples. So how we can use visualizations and developing models connected to the way we make sense of complexity to explain systemic developments, and also an example about real-time monitoring. The disclaimers, of course, always apply. These are Enrico and my views. These do not reflect those of the ECB. But also there is another disclaimer. We prepare some data for you and some visualizations. Of course, due to confidentiality, we have to anonymize and change something. So we prepare something for you, but it's important that these numbers do not really reflect and real developments, and they are for educational purposes only. So who are we? Like, what do we do? What is the SRB? And why do we need data? So the SRB is responsible for the full macroprudential oversight of the whole EU financial system. So we have a broad remit. We cover banks, asset managers, any kind of financial institutions, and also financial market infrastructures. And in order to accomplish our objectives, we need to analyze all the relevant information. What does it mean that we have to analyze all the relevant information? What does the law tell us that we have to analyze all the relevant information? The reason why we need to do, I think, was expressed very well by our former chair, Mario Draghi. And he said during 3 years ago's ESRB annual conference, he said something very interesting. That is that if we want to monitor a very interconnected financial system, we need detailed and granular transaction data. So, and in order to really have the full picture of the system, we need to be able to link this data. So these are the 2 things I'm going to talk about today. But also, more technically, what we need is data that is both at the high level of granularity and also at the high level of frequency. And it turns out that we do have access to very granular and complex data. Here, just an example. This is not all the data we get. We get data on transaction by transaction daily on derivatives. You know, derivatives were one of the key instruments at the onset of the global financial crisis. The size is quite big. We have about 300,000 reporting entities, so counterparties in the system, financial entities, anything that you can think of. And the data is about 100 million observations per day, contracts per day, and the total data set now exceeds 150 billion records in the data. Then we have recently onboarded data on repos. This is, I think derivatives are very well known because there are movies about it. The repos are a bit different, but they are also important instruments. Also collected daily, also transaction by transaction, we have about 9 to 10 million observations a day. We have data on alternative investment fund managers. Okay, if you want to be a bit more, say, more general, like hedge funds, this includes hedge funds, where we have holdings, risk profiles, and the counterparties they engage in. We're starting to collect data on securitizations, and we also have a loan-by-loan data from the ECB, which is about 30 million loans per month collected a month. So you see, this data can be very complex. So how do you tackle this? We have to do one job, that is to constantly go from micro to macro. This is what we do constantly. And in order to do this, we create a sort of a pattern, an analytical life cycle that we use to identify, analyze, and communicate. Very importantly, conveying information. And here is the key, I think one of the key aspects that I would like to explain to you is that we have to go at all levels. So we can't just explain things between myself and Enrico, but we also need to go at different levels. We have to explain to a variety of people with different backgrounds, and also managers that have to understand what can be done, where risks lie, and what can be done. Now, we have lots of data, we have new tools, but we have always the same old problems. And I'm using here 3 fantastic comics from SKCD. No matter what you do when you analyze data, no matter the models, no matter the visualization, whether you do some cure fitting to analyze patterns, whether you run a model and you want to check statistical significance, whether you also do machine learning, whatever you do, you always enter in the issue that you are trying to find confirmation of what you want to see. And this is exactly the opposite of what we have to do. So we always tell everybody that comes and join us, we have to refrain from finding confirmation. We have to let the explanations emerge. This is a complete different thing. So let's say if I'm going to give you a short step-by-step, we have to embrace the complexity. We don't need to fear it at all, but we need to build first intuition. We need to have a good mathematical and statistical representation of the data that we see. And we have, again, to let the interpretation emerge rather than finding a story behind what you want to show. This is always very complex. It's a bias, and we really need to do so. Why is that? Complexity can be very deceiving in the financial system. I'm going to show you an example of where complexity can really be deceiving and lead you to wrong decisions, and especially how visualization can help you with that. So you're familiar with derivatives. You heard about them. In particular, you're probably familiar with credit default swap, which were popularized in movies like The Big Short. And these are big. There are trillions of contracts that are around the system. So if I'm aggregating all the data that I get and I just plot a time series, well, I see these volumes spiking across the financial crisis and then crashing down, right? So I'm aggregating all the thousands of contracts here, and I'm plotting a time series. Well, if I go to my boss and say, look, I see low risk, do I see lower contagion? Do I see, more technically, less demand for hedging and protection? Will I observe lower margin calls in case there is a market shock? Well, the answer is not that simple. It's true. The aggregate data is going down. You see a time series going down. But what is really driving this change? Now, imagine that we can take all these contracts and write a sort of map with all the contracts that we see in the thousands of contracts, hundreds of contracts that we see in the system. And we want to create a sort of metro map of all the contracts and the counterparties interlinked. This is an example. So here we took the data, we plotted a network, and this network shows two key facts. The first fact is that the risk these instruments is flowing from left to right, from the buyers of credit default swap to the sellers of credit default swaps. But remarkably, 80% of the volumes are all between big dealers. Okay, so when we hear these huge numbers, trillions and trillions, we have to say that 80% is only intra-financial intermediation. Okay, so this is the first fact. This is not what people typically argue, that these derivatives are needed by non-financial corporations or small players to hedge. No, the vast majority is completely intra-financial intermediation, okay? And this emerges from granular data. How do we create a model of this? And we need to stylize a little bit. We need a little step forward, and we can use visuals to help us create the model. So imagine that we have to stylize the model. We see some interesting patterns. Essentially, all derivatives market can be mapped in this way. There are very few exceptions. All derivatives markets have always end and customers and dealers intermediating. Imagine like a car dealer intermediating, except that they are intermediating trillions of dollars of derivatives. What we emerged, there's a pattern in this data, and this data shows that clearly there are some cycles in the derivatives. So there are banks that are mutually exposed, except that they don't know that there's a third bank that has the same amount. Now, A owes 1,000 to B, B owes 1,000 to C, C owes 1,000 to A. Well, we can as well remove them, right? So imagine that now we are removing all these contracts from the system, and this is what drives indeed the time series, the aggregate time series. You may think this is magic, not at all magic. It really happened like that. And this is just to show how aggregate developments can be incredibly deceiving. You have to go granular to really understand what happens. Now, I talked at the beginning, do we see less risks in derivatives because of this reduction in notional? Well, not at all. What happened in March 2020, we had what can be regarded as the biggest margin call in history, and we had the data to look at it, to monitor. And I think here Enrico is going to tell us something about it.
Yes, thank you, Marco. So often by going through the steps that Marco has just explained, we find interesting dynamics that we want to monitor regularly. For example, thanks to the exploration and models that we have built using the granular image data, so data about derivatives, and also data that is really granular because covers transaction by transactions and also covers margin calls. So thanks to this exploration, we were able to create a live monitor of the margin calls. And this monitor has been created using Tableau. We can probably show the Tableau dashboard. This is, of course, most of the EMIR data is really confidential, so we have masked the name of the entities that are involved. and we don't show anything that we have not already shown publicly. But anyways, so this kind of dashboard, this kind of monitoring came really useful during the March 2020 market turmoil, when we had the largest margin call.
I'm going to buy you cereal to see I'm coming back.
To history. So as you can see on the left, you can see that the dashboard, from the chart that you can see at the left, the dashboard starts with an aggregate and easy to understand chart that highlights the macro evolution of margin calls. So margin is usually exchanged between CCPs, central clearing houses, and clearing members, which are usually big banks. We have noticed, for example, that one of the issues whenever there's a spike, or anyways, the evolution of the variation margin exchange is usually driven by a few clearing members. So there's a few entities. And if we click particularly on one spike in the time series, here we're investigating variation margin. You can see on the upper right chart, bar chart, highlighted in red for each CCP that we have in our data set. You see highlighted in red the chunk, the share that is due just to the 5 biggest clearing members. And if you click further, you can see in the bottom right chart, highlighted the evolution of the notional that is cleared in that CCP. So basically that it's traded using that CCP by these clearing members. This can give, this is of course a useful monitor that can be used to continuously understand the evolution of the derivatives market, and particularly is designed to be understood by manager and decision makers. So this is something that we don't use. This is the outcome of a work that went to the complexity and has been done mainly by more technical people that are more data literate or data proficient, and now can be used by decision maker and can be used to monitor by anybody in our team.
And Cloda, if I may have one last slide, because you asked us what kind of skills we're looking for. Yeah. And also in case you're interested after this talk and try to have a go at this kind of career, we are hiring, especially for students. Now, the 2021 campaign, unfortunately, is closed. We hired already, but if you're interested, check out the vacancies in the next spring.
Great, thank you. Okay, so we're a little bit over time, but not too much. And I think that's been an incredibly useful overview from all our guests. So thanks again to all the panel members and to my colleagues on the committee who helped crowdsource all these panel members.